Hello everyone, I'm Christian and today I'm going to show you how to solve a machine learning problem using an example. In this example, we are trying to predict the median housing price from different districts using the database from Californian Census of 1990. First, we need to frame this problem. Is a supervised learning because we have all our examples labeled and is a regression task because we are trying to predict a continuous value, not a category. So first, we need to download the data from GitHub and load it into a data frame using pandas. Now, when we get the info from this data and the features, we can see some problems here. That the total bedrooms has some missing values and that almost all the features are numerical. Just the ocean proximity is a category. Then, when we plot the histogram for our features, we can have some insights that the median income is scaled and capped in at 15, and the median housing value is capped at 500,000, and we can see that the scale from different features has a vastly difference. For example, total rooms has a range from 0 to 35,000, and median income has a range of 0 to 15. So we will need to feature scaling. And also we can see that the histogram is right scale, right skewed. This means that to address this problem, we will need to make mathematical transformation. Eh, then we will need to set aside 20% of the data for the testing data, and this should be randomly. Commonly is using the scikit-learn coding for avoiding the problem for running the coding different times and get different test set. If for as we know, the income is the stronger predictor for housing value prices. So we need to stratify the sampling to get accurate represent the real world income distribution. So we bin the median income into 5 categories using the function code and split the data using a stratified Shewell split. And this ensure both our training and test set mirror the exact same income proportions. Then we are going to visualize the data and find correlation. So we plot the latitude versus longitude and we can see the map of the coastal side of California, and also we can make a heat map to say to see the population concentration of California. Then when we have the matrix correlation, we can see that the median income have a strong relationship with a correlation of 0.68, almost 69, and then we engineer some three more features, and we made the correlation matrix, and we can see that the bedrooms per room have a relationship of minus 0.26. Then we need to address the and prepare the data for the machine learning. So for address the missing values problem, we use simply imputer with the median strategy to fill the gaps in the bedroom column. And to address the problem of the categorical feature, we avoid to use ordinal encoder because it implies a false order between causal categories, and we use what home encoder to create binary variables as we see here. Then to make the feature scaling, we apply a standard scaler to normalize all numerical inputs. Then we pack all this into a single column transformer to handle both numeric and categorical tracks simultaneously, giving us a matrix ready for training. So finally, we train and evaluate two models. First, linear regression. Testing it with root mean square error, we can see an error of 68,000. That is a high error. This means that our machine learning model is suffering from underfitting. And when we use decision tree and we evaluate it, it gives us an error of 0. This means that our model is overfitting. Thank you for your attention.